here. Hey, it worked. All right. Yes, okay. I was just going to ask if I hit record, and then I saw the little recording thing. Cool. So hello, everybody. I'm going to talk about some bilateral trade flows, and I'm going to use MPSGE since this is the MPSGE monthly. I won't go into super detail about it, but I'll point out some of the interesting little features. And before I go too far, I should mention the WinDC website, because if I click resources, seminars, and then the monthly, you can see I have everything there, including a draft of the slides, a paper right here. This is by Ed, Tom, and Steve Zonizer. And it's basically what I'm working through now. So if you have more questions, they'll probably elucidate that a little better. And if I go to About and Blog, I've been writing a blog on Fridays. I haven't advertised it too much because I wanted to make sure that I could keep it up and keep it interesting. But some of these are actually relatively useful. So you can check that out. And yeah, I like the GTAP and the visualization and the development tips are good ones. Okay. But this is the paper. There we go. All right. I'm going to talk about bilateral trade. So, what state exports the most soybeans? I think May was here on Tuesday, so she already knows. The probable answer is Illinois or Iowa. They produce the most soybeans. But of course, the largest exporter is Louisiana. And if you think about this, it doesn't make sense until you realize they're actually reporting the last state it touches before it actually gets exported. So all the Midwest soybeans come down the Mississippi, hit New Orleans, and then they go out, and they're being recorded as exported from Louisiana. So this is technically correct, which is the best kind, but it has obvious issues. So there's only the last port that it sees, and it doesn't really tell me anything about what Wisconsin is doing, or Nebraska, or Illinois, or Iowa. Like, I want to see the impact of these tariffs on Wisconsin farmers. And then I want to make a sign and put it in my yard so all the farmers see it. Okay, so I've just grabbed some data, and I'm not trusting the data completely because the total production is less than the total exports, but they come from two different sources, so I'd have to reconcile them a little bit. The one on the left is cash receipts. It's in millions. The one on the right is from USA Trade Online, also in millions. But essentially, what we see here is that Louisiana produces 1.3% of the soybeans, but exports 42%. So the idea that we want to do is change the export number to match the production share. So instead of Wisconsin exporting 0.63, we move it up to 2.2, and that is what it is exporting. So I did that calculation down here. Just straight multiplication. This is oil seeds, soybeans. And then if I further break this down, 480 will go through Louisiana, 232 will go through Washington. So total exports, and then break them up by export share. But if you look at Wisconsin, Wisconsin is on the east side of the Mississippi, and it's connected to the Great Lakes. So why should Wisconsin soybeans get on a train and go to Seattle? And that brings us to one of the issues, right? So, like, logically to me, it would be cheaper to send just a barge down the Mississippi or load up boats like through Green Bay and have them go out through like the St. Lawrence waterway. But again, that could also be wrong because if it goes down south, like, how does it get to like Asia or where it's going? So there's different trade costs associated with this, and we want to be able to incorporate that when we build our when we actually calculate the trade. The other problem is that production shares can be too high, and most of the corn and stuff grown in my area, they're harvesting it now. It goes to dairy cows for the winter. Dairy cows eat it, or pigs, or whatever. So the solution here is a structural gravity model. and it'll maintain production and absorption levels, and incorporate trade costs, and it'll actually be responsible to changes in trade policy, which I think would be very nice. Okay. So I'm just going to set up a little framework. I'm going to do a little example, and I'm going to disappoint everybody by not using real data right away. I wanted something that was a little bit that would run in a timely manner and allow me to just talk about what's going on. So I just going to use 3 states, 3 goods, and 3 countries or ports. You can think of them as sort of interchangeably. They just have exogenous imports, exports, essentially, stuff coming in and going out. So each state is going to have a balanced I/O table with foreign exports and imports, and consumers have identical and homothetic preferences. So just things act nicely. We can model this stuff nicely. We want to use CGE. So, and the outcome we want to be able to estimate the trade flows be state to state and state to port or country. I can't read. Sorry. I do math, not English. We want the state production and absorption levels to be preserved, and we want to preserve the trade flows, right? International and intranational. So before we go too far, the Julia code for this is in a GitHub repo that's linked on the MPSGE monthly page. If you want to install Julia in VS Code, I have a link here. It'll walk you through it. You can clone it, open the folder in VS Code, and just shift enter on main.jl, and it'll take care of everything for you. And what is everything? Where is this one? So what I mean by everything, here's VS Code. I've opened main.jl. If I run these 3 lines of code, it'll start an environment in the folder that I'm in, and then it will install all the required packages. And if I click project.2ml, these are the required packages. If you know Python, this is like requirements.txt. So it's creating sort of a little virtual environment. And I don't know if R does that. Yeah, but this is how it works. This file right here, gravity example, that's the name of the project. I should click here. You can see that here. So if I click gravity example.jl and source, you can see everything that gets included. This defines the module, defines everything I get to use. Okay. So I'm going to use VS Code quite a bit here, starting about now. Because we're actually going to look at a little bit of data. The process is that we build the tables, calculate shares, build our model, solve our model, and then rebuild the shares, or rebuild the trade data. It'll start frictionless, just with production shares and export shares, and then we'll actually add our data to it. Okay, so let me close most things here, just so I can see it. And I'm going to show off a couple of things here. So there's a function called create data. You'll never guess what it does. Creates the data. And this is what's called a simple table. Now, simple table is something that I've defined. It's literally right here. And it's a subtype of an abstract table, which is a subtype of a WinDC table. A WinDC table, this is part of the WinDC container package. Basically, all you have to do is define these functions right here, and you end up getting a lot of power. Power that comes from this package. So I just had to tell the domain, it's going to have a row, a column, and a state. Row meaning like commodity, think of an IO table. Rows being like commodities, value added. Columns being sectors, exports, imports. Like looking at an IO table, that's what you'd see. And then I give it the data and the sets. And what power do I get from this? Well, if I look at X, if I just look at it, there's 3 data frames, one with the data, one with sets, and one with elements. And I can pull those out individually with table. I guess I would do sets next, right? So there I can view the table. Here I can view the sets. And here I can view the elements. Nothing really too interesting here. But let's say I just wanted to view the commodities. This is pretty easy to see because I can just sort of see it's not big. But I put the set name, then it just pulls out the commodities. I can do the same thing in the table. And this is going to filter that so it's just commodities in the row. So it knows where it is. It knows how to pick it out. I think I can also do, oops, it needs to be a symbol. I can just pull out intermediate demand on the, I guess saying commodities there is kind of redundant because that's going to be the it's part of the domain. This has all the states mixed in. So I could explicitly tell it a state. I believe. So this is the name of the column. This is the element that I want to pull out. So it just pulls out state 1, which is nice. Another thing to notice, there are all these values are negative. By convention, I take inputs to be negative and outputs to be positive. So if I change this to be supply, they're all positive. You might wonder what the advantage of that is. I go back here. Okay, so here's what I'm going to do. I'm going to take just the commodities. I'm going to do a group by state. Okay, if you don't know what a group by is, it's just a data frame operation. And it just groups. So because I group by row and state, everything in row and everything in state is going to be the same. And if I add up all these values, if the data is actually balanced, they should add to 0. And it's going to be very, 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 very funny if they don't. Oh, they do though. Hey, all right. So the way that I'm creating this data is, okay, it's a function called create data. It's in data. Let me minimize this. So here's what it does. I have optional arguments. You can specify goods, sectors, and states. I would keep them at 3. There could be bugs. I have to clean this up a little more. Define the goods. Define the actual like elements of the sets. Define the actual sets. So intermediate demand is a parameter. Commodity, it sits inside of the row. Set up the elements. So the goods, the sectors, the states, pretty straightforward. And then the actual data, it's all random. Nothing too interesting there. And then I calibrate. This calibrate function comes from WinDC container. And the actual way that it calibrates is going to be calibrate. So they do, and this just tells it to overwrite the function from the WinDC container. It takes in a model and a table. And essentially what it's saying is the market clearance condition should be 0 and the zero profit condition should be 0. So row sums and column sums. Nothing too groundbreaking. But the point is that that's all that I need to write. And it automatically calibrates, which is very nice. I don't have to worry about extracting stuff. It does it all automatically. Okay. So that's a really, 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 really quick overview of WinDC container. It just sets me up with some really nice functions that I can extract data and view it and look at it and use it. And also, when you actually are writing a model, it's inconvenient to have these be negative because you don't really want negative values. So I have a normalize equals, apparently I haven't run this. So when I type normalize, it's just going to flip all the signs. And because I'm telling it use, it knows what's in use, and then it makes everything positive. It's more of a convenience function for modeling. But 99 times out of 10, it's easier to have the actual signs. 99 times out of 10? Yeah, that's right. It's easier to have them be the signs because most things you can just, it's a group by and then a sum. Most things. Okay. So that's how I create data works. Trade is similar to create trade. It's just a random data frame. I don't try to match up imports, exports because that's not going to happen in the real data. So I'm just not too concerned. And if it does happen, that'd be great, but I doubt it. And then finally, the regional trade table. And this is what I'm actually going to use to build the bilateral trade. So what does that look like? That is right here. It's another WinDC table. And let's just look at the table. There we go. This one does not have any signs on it. It wasn't necessary. I just kept it all positive. It's essentially just for modeling. So things can just be positive. Whoop. I think I have that being capital. There we go. I can see the imports. The origin is a country and this destination is state. And again, you can read this as country or port. It's just an arbitrary name of assigned. I think there's also intra-national. I think I also have a function called absorption. Nope, it's called reference absorption. So that's just how much is ending up in each state, how much of each good is ending up in each state. Also, I should say the one nice thing about Microsoft products is that it all sort of gets mashed together. So this is Copilot trying to figure out what this should be. I don't know why it thinks that, but it is actually quite useful. Like, for example, when I was writing, hold on, this slide, I typed in 0.426 and it filled in everything with the math correct, like Louisiana and Washington. Was it hard for me to do? No. Did I want to do it? No, I did check it, but so I'm not going to trust it. Okay. So that's the setup. That's just the data. I think most people here have heard of MPSGE, but in case not, in case somebody's watching the recording, this model is written in MPSGE, and this is the repo. You should think of MPSGE as a high-level language for writing computable general equilibrium models, CGE models. It abstracts the structure of the model into inputs and outputs, so you just have to focus on what it looks like and not have to do the calculus. And this package will create and solve models. It'll do it faster than the one in GAMS. I ribbed Tom with that quite a bit, every opportunity I could, partially to get him to be motivated to do MPSGE version 2 in GAMS. It was unsuccessful. However, mine is fully open source. You can fork it. You can do whatever you want. The documentation does need work. That's on me. Just reach out if you have questions. It'll motivate me to write the documentation. It'll make me interested in it. And if you're using it, I want to know, because I think that's cool. Also, then I can tell people that you're using it and be like, look, you should fund me because people are using this. To understand the model. Okay. So I'm going to talk about the model. I just sort of started reading there because this is going to be a little bit different. I think some people watching this are IO people, and this is definitely a CGE type structure. And there's a couple of subtleties going on here. So in our model, I'm going to look at absorption. And absorption is defined as the sum of international demand or international flow plus imports, right? It's everything going into the state. I don't have to worry about a balance here because I've defined absorption to be the sum of these two things. I've written these as negative because they are inputs. That's fine. They won't be negative in the actual thing. I'm just, it's a convention. Okay, here's the important thing. At the benchmark price, all of the prices are 1. Or at the benchmark, all of the prices are 1. So whatever the price is, I have the quantity, the total value is just the product. Okay, this is a pretty easy math problem so far. The problem is when we introduce the trade flows, when we actually introduce the gravity condition, we are going to adjust the prices. And if we adjust the prices, we don't want to change the quantity. So we have to change the value. So that's exactly what we do. This is some trade impedance on intrastate, and this is some trade impedance on imports. For now, in this model, I've essentially made these numbers up. In the real model, they could be anything. They could be centroid to centroid distance. That's kind of the easiest thing. You could actually route out paths. That's a little more fragile, but it'd be much more accurate. Which is great. The problem is that I need to multiply. And this is a real subtlety. Okay, I'm going to show you where this comes up in the MPSGE model. But this table also doesn't tell me everything I need to know. This is the actual structure of the MPSGE model. So in the absorption sector, I'm just going to pick a good and a state. It's just going to output whatever the absorption is. Typically here, I also write quantities. So this would be PA. I'm going to go back one. It would have this quantity on it. It just got really busy. A lot of stuff to type in, so I suppressed them. The inputs, it can either pull it from its own state, or it can enter a pooled market from the other states. So essentially, it's a little bit easy, like it's nesting. It's separating elasticities out. Same with imports. You can either get it domestically or internationally. And domestically, you can either get it from yourself or another state. So this is the actual structure of the model. These are elasticities. Domestic equals 2 sigma. So the elasticity between these two is 2 sigma. And the elasticity between all of these is 2 sigma and 4 sigma down there. Okay, so let's look at this, how it's actually defined. Here's the actual model. I have my parameters. So you can see tau D, tau M, and tau X, domestic, import, and exports. I'm not currently using this one, but I'll show you where it is and what it's doing. 2 sectors. This one is fake. Xsec is fake. I'm just using it so I can extract more information a little bit more easily. But this is our absorption sector. All of our prices. This model is a little bit finicky because some prices want to go to 0. So I put a lower bound on them, which is fine. And this one is also fake. I've just made it so I can easily get stuff out. Okay. There's a couple of auxiliary variables. I'll talk about where those come in. Just think about auxiliary variables and MPSGE as other variables. So I'm able to pin things down a little bit. And then this is the model that I just showed. This is the exact tree that I just showed. So there's a top level nest T and S. Import sits below S and domestic sits below S. So that's the tree. And then national sits below domestic. I think if I click here, oh, I went one forward. So that's exactly this tree structure without the leaves. To add the leaves on, that would be right here. So like PY, this is S equals S, so it's sitting below domestic because the states are the same, and it pulls out international. Same with this one. I filter the origin so it's not, so the states are different. Pulls that out. And the one thing to notice, the quantity is adjusted by that tau, and the reference price. The reference price calibrates the price. So inside of my cost function, it's PY divided by reference price. So the actual price is tau times PY. So you gotta put. So this is adjusting the price. This is doing the work of this right here. That's what the reference price is doing this, saying the price is actually that. It's much more commonly used for taxes. Like you put a tax rate in, but the price already has that built in. So you do a reference price of the tax value with the benchmark, because then it cancels out. So the price is just 1. It makes calibration easier. Okay. The rest of the model, this one is just gives me a way to access exports, because I have exports here. Just saying exports across all states have to add up correctly to be the sum of the exports. Makes sense. Final demands. This one is the fake one. This should really be like PY, I believe. But that's fine. And then right here, representative agent. Just basically everything is taking in foreign exchange. So I'm going through this fairly quickly. I'm not focusing on this part because it's a little bit more in the weeds than I want to go, but I do want to look at the auxiliary constraints because this is where that SY shows up. What we do is we fix this number to be 1 and this number is 1 in our first solve. So we lock py to pfx. So they're always the same. So in our initial solve, they'll be the same. And then what we'll do is free this up and let it float around so those two can vary. So this model is a little temperamental. In our first solve, it's very possible that we push it too far and it falls out of convexity. So by pinning them to be the same, we sort of end up in a neighborhood where it stays convex. And then we free it up. It doesn't, like, the problem needs to be convex, otherwise it's intractable. Set a numeraire, and that's the whole model. If I look back here, all right, now I get to talk about how it solves. It goes through 3 solve stages. Solves, the first one is at the benchmark. So you just want to make sure that the model is actually calibrated. I would like to say that I've never made the mistake of having a model not be calibrated. That'd be a lie. Set the trade cost. So the first solve is just calibration. The second one is we pin these two to be 1. So we just set these, essentially fix these two values to be 1, and then solve to find a stability point. That's that neighborhood. And then we unpin these and solve to find the new trade flows. How is that implemented in MPSGE? Right here. Solve the benchmark. That's what cumulative iteration limit equals 0 means. Let me do one thing here. Hold on. So in VS Code, if you highlight lines like this and run it, it only runs that little section. There we go. Oops. So I've just redefined my model M. Now I just want to solve this. So benchmark solves, that's good. That'd be very bad. Okay. This is where I'm setting the domestic trade values. I'm just setting these to be 5 if S1 is not S2. Within state, I set to be 1. You know you don't want a distance of 0 for division by 0 reasons. But if the two states are the same, it's 1. And if they're different, then it's 5. For an iceberg, I've found a lot of instability issues when these values are different, which I guess would make sense. So be aware. But if I do this, so here I set the parameters, fix the values. So these are just being fixed to be 1. And then I solve, and it actually does solve. It was took a little bit longer. And then for the last solve, exactly like I said, unfix the auxiliary variables, bound them as well so those values can't deviate too much. Again, to find that little neighborhood, solve it. It actually solves. And then I can reconstruct the table. So the tables T and N represent the same data, just assembled differently. And I have an actual visualization here, but just sort of looking anecdotally. So for state 1, the value at T, you're just using trade or production shares, was like 1.3, and then it'll get boosted to 3.2. So the good flow from state 1 to state 1 increases dramatically, and that's kind of a recurring theme. And it makes a lot of sense, right? So what happens is soybeans grown in Wisconsin, probably going to be used in Wisconsin. That's what this is saying. That's essentially it. Especially given that I made the trade, or I made the import exports be quite large. So it's discouraging that trade. Okay. Absorption should be conserved, which it is. Production should be conserved, which it is. And now what I'm going to do, I think the best way to view this is a heat map. And I think I can see these colors. I'm slightly colorblind. The upper right portion is country to country. We don't model that, so it's always 0. This, I believe, is exports. So rectangle here is exports. Looks like they are not changing at all. You can see the values of 10 to the minus 16. Imports, here they dip. So it's old or it's new minus old. So the import from state or country 1 to state 3 is going down by like 0.2. And these are actual numbers. So they're not pinned to a numeraire. These are coming back as like actual quantities. But as I said earlier, within state, they go up quite a bit. So this is going up by 3, by 1, or by 2, by 2. And the state-to-state trade goes down quite a bit. So I think that's really kind of interesting. It fits the intuition. It fits that intuition of grow local, use local, right? And if I shrink these down and raise this up, oops, that's 2. I have it set up so it just runs that whole block, so I don't have to rerun it every time. That's why I was doing it bit by bit. Okay, good. It's solved. Always make sure that it's solved because it may not. And I have functions to do that. So if I adjust the trade flows even more, I don't like that though. There might be a bug. I don't like the exports don't change at all. But changing the values affects this quite a bit. Yeah, this goes up by 5. I think it went up by 3 last time, 4.5, 3. So interesting little things. Okay. I should show you how I actually do rebuild the table. It's essentially this command right here. Value X, value P, and compensated demand. Hey, Drew, if you want to ask, go for it.
Hey, thanks. Just out of curiosity, I know this example is using made-up data,
Yep.
but just to be clear, I mean, this result stems from using a distance decay function. Is that right? To
Yeah.
penalize trade for farther. Okay.
Yeah. So the farther away things are, the less trade you expect there to happen.
Okay. Yeah. Got it.
Yep.
Thank you.
Yep. In other words, the bigger this number, same thing. And I can add functionality and so that this is actually more dynamic. I'm just setting them all to be 20. No other reason.
Got it.
Oh, and I should show you. Oh, sorry. Okay, and as you can see right here, value of S times C times compensated demand. I'm doing them all separately because it's more efficient. It doesn't have to build like another jump expression. It just multiplies numbers instead of expressions. And I have this little option that says virtual equals true. Basically, does it want the whole expression or just the cost functions divided? In the back end, MPSGE stores the cost function value as an actual variable. So the virtual equals true just pulls out those variables. So it's much more efficient. And the way that it reconstructs the table is it just finds the quantity. It's doing exactly what I mentioned it does. Just builds that whole table out again. All right, so where do I see this going? First, I need to refine. I missed an E. I need to refine the model to extract more information. How did I miss the E? Usually AI is my spell checker, so I must have spelled it wrong enough that AI figured it out that I spelled it wrong. But using this, we should be able to compute trade flows within the US, bilateral trade flows between Wisconsin, Nebraska, Texas, things like that, and the actual ports of origin destination. Should be able to integrate with GTAP to compute international trade flows. Where do things grown in Wisconsin actually go? Like the cheese in Wisconsin. I'm going to guess it doesn't get imported to Switzerland, but some of it might. Make more subnational models. We should be able to link up Canadian provinces. I've looked through Canada's available data, and it's actually really quite nice. They have much more data in a much better format than the US provides, so it should actually be pretty easy to get bilateral trade flow on Canadian provinces. And then just need to match together how it matches up, right? Okay. I've left a lot of time for questions. If there are none, that's totally cool. Or if there are more, that's cool too. But I should ask, are there any questions? Go for it, Drew.
Thanks. And thanks for going through this work. Subnational trade is a tricky one.
Yeah.
So very, very cool. Yeah, so a couple questions. Do you, I mean, I think the impetus of this work was around ag, where there's
Yep.
like a pretty obvious difference between like what's in the census trade data and what's in like production data. And have, is the anticipation, or do you anticipate using this framework for other commodities in the data set?
I'd like to. I'd like to try it out, see how it goes.
Yeah,
Yeah. The end goal would be to have a table that is um like commodities, sectors, state one, state two, origin, destination.
yeah.
Um, that's a heavy data set, but I think it'd be really useful.
hmm Yeah, I'd be curious to see how it goes. Like I'm not personally familiar with other instances where there's like a big discrepancy between like census export data and like
Yeah.
other sources. So I'd be curious to know if there are other sectors in which sort of this port problem is an issue, you know, or
Yeah.
if
If
there are
anything,
other things shipped down the Mississippi, then probably it does persist, but I don't know.
yeah, I know a lot of metals and stuff from Wisconsin and Michigan just go through the lakes.
Okay. Yeah,
Yeah.
so that'd be really interesting finding. And then um yeah, I'd be curious also like, for goods that are you can put in trucks or put on barges, like um, the this type of framework I think makes a lot of sense. And I wonder like how to handle like service trade and things too, because that's a big chunk of the economy. And depending on the sector, it's like trade and financial products. Like I don't, I'm not
Yeah.
quite sure how to think about that. So it, uh, maybe a gravity framework could be used, and the impedances are just based on something. I don't know. I don't know how it would work, but it just kind of an interesting question as you kind of pursue some of this work that I flag.
Yeah.
Um, and just quickly, I will say, uh, Virginia is pretty far from Wisconsin, but I'm still able to find Wisconsin cheese in Trader
Oh yeah.
Joe's. So there you go.
Oh yeah. Wisconsin makes more cheese than anywhere else.
hmm
It's pretty wild. Yeah, I once had a discussion with somebody, one of my former professor's husbands. He said, I don't see why Wisconsin cheese is special. I can go into a cheese shop in Boston and get really fancy cheese I want. And I said, yeah, in Wisconsin, I can go anywhere. Go to a gas station.
Even the local Quick Trip. Yeah, exactly.
Exactly. Go to Quick Trip. And we might get a Buc-ee's. I bet they'll have cheese there too. Um, yeah, I see this work as having a lot of potential. Um, yeah, I think it'll be good. Oh, and I should say Tom and Ed. Oh yeah, I pointed out the paper. Tom and Ed have a paper on this. Really go into more detail. Again, they do agricultural sectors because that's the driving force. Um, yeah, but I mean, if the data for other sectors is better, that's great. Because if it actually works out and we don't like we need uh, weaker assumptions, that's better. Better data in is better data out. Yeah. Yeah, go for it.
I sorry, just as you were talking, I remembered one more thing I wanted to mention was so for the ag example, like um, the big motivation there is this difference in exports. It would be also really interesting to get a sense for how some of the bilateral trade flows between states look relative to what's in WinC now, which is based on the FAF
Yeah.
data. Um, and the FAF data it only exists for things that you can ship on like trucks and things.
Yep.
Assumptions are made for services, but that would be pretty cool because it, you know, that data doesn't really net out transshipments, I think, which your framework would. So again, just another plug for lots of potential improvements in trade. So.
Oh yeah. Yeah, I think there's a lot of rich opportunities there. All right. Sorry, do the teacher pause. Okay, cool though. If there's nothing else, I can let everybody run free, go get lunch. Hopefully on the East Coast, you've already eaten. Yeah, if you have anything else, always feel free to reach out. I'm very responsive to the email. I have about 4 of people trying to join and not being able to that I get to respond to right now.
Well, thanks,
Cool.
Mitch. This is
Yeah,
great.
anytime. Stop share as well. There we go. Cool.
Yeah, thanks. It was great.
Thank you, Mish.
Have a good one.
Yeah.
Bye.